Hello everyone, this is Redemma, Assistant Professor, Artificial Intelligence and Machine Learning, Annamacharya University, Rajampet. Today I will discuss about the graph neural networks architecture. First we have know about the what is graph neural network. Graph neural networks are a deep learning models designed to operate on graph structured data, unlike CNN for a grid-like images or RNN for a sequences. GNN directly handle the nodes, edges, and their relationships. Graphs are represented as a G equal to V comma E, where V represents the set of nodes and E represents the set of edges. The basic architecture of graph neural networks are message passing, update the function, read out the or graph layers. Here we showing the some architecture topics, graph convolutional networks and graph attention networks, and also graph sampling and aggregations. First we have to know about the what is graph convolutional networks. Graph convolutional networks are one of the most fundamental architecture in graph neural networks. They were introduced by Thomas Kiff and Max Welling in 2017 for semi-supervised node classification on graph structured data. In graph convolutional networks extend the idea of convolutional from grid structured data like images to non-Euclidean data such as a graphs. Here showing the grid. Grid means structured data like images. And other one is real-time example of a data semi-supervised learning data. It's showing the graphs and also calling the non-Euclidean data structure as a graph. It mainly motivates the traditional neural networks assume structured inputs. In structured inputs, one of the structure is CNNs assuming the grid structure and another one is RNN assume the sequential structure. However, many real world systems are naturally represented as a graphs. Some examples are here social networks, citation networks, and biological networks, and another one is knowledge graphs. Graphs are irregular, each node can have a different number of neighbors. Therefore, defining the convolutional directly on graph is not a strategy forward graph convolutional network solving this by defining the convolutionals in the spectral domain and simplifying it for practical implementation of graph representations. Here showing the graph convolutional networks. Here taking the target node neighbor smoothing mechanism. First we have to taking the input values from different sources. Step 1 we have to collect the different future values or patterns. In second step information aggregation and third one is future smoothing. Here showing the autonomy of these graph convolutional networks propagation rule. It simplified the average the neighbors and normalized the based on degree of transformation linearly. Graph convolutional network strengths and limitations. Here showing the some strengths and limitations of a graph convolutional networks. Elegance, efficiency, performance, And limitations are isotropic, oversmoothing, and memory. And here showing the architecture to graph attention network. First we have know about the what is graph attention network. Graph attention network were introduced by a Peter Velikon in 2018. Graph attention network incorporate the attention mechanism into graph neural networks. It enabling the nodes to assign their different importance weights to neighbors. It mainly motivated all neighbors contributes the equal. Here showing the graph attention network mechanism calculate the coefficient of the values of linear transformation into coefficient values of concatenation. Here multiple independent heads stabilize the learning processes, capturing the different types of relationships simultaneously. Here showing the comparison table of a graph convolutional networks and graph attention networks aggregation. Here the statistic approach of the target mean value of neighbor A, neighbor C, neighbor B. Here targeted values are 33%, A, B, C, some equal parts of percentages. Then graph attention network, the adaptive approach of the targeted values. And the next third architecture is graph sampling and aggregation. Simply we call it at the graph sage. Mechanism sampling. First we have to know about the what is graph sampling and aggregation. Graph sampling and aggregation was introduced by William Hamilton in 2017. It is designed for a scaled and inductive representation learning on large graphs. It mainly motivates the graph convolutional networks and graph attention networks, requires the full adjacency matrix. This becomes infeasible for a large social networks and e-commerce platforms and billions node graphs. Graph sampling and aggregation networks solves this by sampling the fixed size of neighbors instead of using all neighbors. It aggregator functions are mean aggregator, long short term memory aggregator, and third one max pooling aggregator. Here we have to follow the working steps of graph sampling and aggregation. First, we have to collect the sample fixed number of neighbors and then go to aggregate the neighbor futures, then concat with the node future values. Then apply the weight transformations and normalize the values in graph sampling aggregation. Here some of advantages are no scalable, and second one is memory efficient, and third one supports inductive learning, fourth one works on the dynamic graphs. Some of the limitations are following the graph sampling and aggregation. First limitation is sampling may lose the information, and second one is hyperparameter sensitivity, and third one is slightly complete implementation. And some of the applications are here they recommendation systems, and second one large scale social networks, and the third one e-commerce personalization, and another one is fraud detection. Here showing the graph sampling mechanism, sample and aggregation. Sample is target nodes are h of v to converted into graph aggregator functions. It mean values of long short-term memory, max pooling values are aggregated. Here showing the architecture matrix. Core mechanisms, key operations, and scalability, inductive, best use of features. Spectral smoothing, attention weights, and sampling aggregation. In graph convolutional networks, features are weighted average and masked the self attention and concat the node aggregated neighbor values. Here is the real world applications bioinformatics, protein folding and molecular property predictions models are graph convolutional networks and graph attention networks. It predicting the bond strength and interfaces interactions. In recommendation systems, social feed and product recommendations, it graph sampling and aggregating. Why? Recommendation systems handling the billions of dynamic users item interactions and efficiently. Here showing the network security. In network security, financial fraud detection is identifying the ringing of a molecule's accounts based on the transaction topologies. Here is the synthesis choosing the right pool. Graph problem is the graph small or fixed. Passed through a is the graph massive or dynamic. It forward to do edge strength very critically. Here showing the graph convolutional networks baseline and graph sampling and aggregation scale. Graph attention network precious. Start simple, add a complexity only when the relation variance demands it. Switches to sampling when scale demands it's a graph sampling and aggregation.